All right, welcome to the last section of Chapter 7, 7.8, coming to you from the Coachella Valley once again, i.e. Palm Springs. Okay, let me share the notes. You got your notes out, ready to roll here. We are factoring polynomials completely. So we're taking pretty much everything we've learned in this chapter practically and putting it all together here. Um, so by the time you're done with this, you will know how to factor all polynomials or all the ones that we're going to cover completely. So that's going to be awesome. Okay, go ahead and do the warm up though. So you go ahead and simplify those. And remember, when it's all addition or all multiplication, you can do it in any order you want. So look for maybe easy ways to multiply. Okay, so pause the video. Here, now I'm back. So here, hopefully you got 60. Now I would look at this and go, I'm gonna do that and make a 40 because that's nice and even. And then 20 added to that is 60. Okay, on this one, I would, hopefully you got 210. And I'm not multiplying 15 times 7. I'm multiplying 15 times 2 and getting 30. And then 30 times 7 is just 3 times 7 with a 0 on the end. On this one, I got 270. Again, I would multiply and get a 10 there and a 27 there. That's easy to do. And on this one, you got 240. And I mean, this is not really hard either way, but I would probably go either the 8 times 5 and get a 40 times the 6 is pretty simple, or 6 times 5 is 30 times 8 is pretty simple. So look for that. Be really active when you do things like that. Okay, here's a little practice on fractional exponents. So go ahead and try those. Okay, I'm back. So remember what this means. This means the sixth root of 64, all raised to the first power, or just the sixth root of 64, which is dos. Okay, what does this one mean? This means the cube root of negative 64 and then all raised to the fourth power. So what is the cube root of negative 64? Well, we know it's going to be a negative, right? Because a negative times a negative times a negative will make a negative. And yeah, it's negative 4. And then we're going to cube negative, or sorry, raise negative 4 to the fourth power, which means it's going to be a positive because it's going to be a negative multiplied by itself 4 times, an even number, and we get 256. And then this one is saying what? The cube root of 216, which is 6. 6 times 6 is 36 times 6 is 216. All right, now we got the juices flowing. Your learning target here is to be able to factor a polynomial completely, no matter what. And we've got all the steps laid out for you. But before we do that, why don't you try some of these? So you're gonna write the product represented by the algebra tiles, then multiply the polynomial and put them in standard form, okay? So I'll do A with you, we can do that together. So this, remember, is an positive X, this is a positive 1, positive X, positive 1, and then this would be a negative 2. So what is that going to look like? It's going to look like x plus 1 times x plus 1 times negative 2. Now, again, we have 3 factors being multiplied together. You can do them in any order you want. But in this case, I would probably just square x plus 1, right? Which we can do very quickly, which is x squared plus 2x plus 1, right? Square the first term, double the product of the two terms, square the last term. And then all I have to do is distribute a negative 2 to that, and I get negative 2x squared minus 4x minus 2. Okay, try B, C, D, E, and F on your own, and pause the video, and then now I'm going to come back. Okay, hopefully for this one, you got negative x cubed minus 3x squared minus 2x. For this one, it was x plus 3 times x times 2. Personally, I would multiply the x and the 2 first, and then distribute the 2x to the x plus 3. On this one, I would do the difference of 2 squares, right? Because these are conjugate binomials, and get x squared minus 1, and then I would distribute that x to it. And let's see, on this one, yeah, we have, if you think about this, this is like almost, these are conjugate binomials. If we wrote them as 1 plus x, 1 minus x, and then I would distribute the negative x. And on F, you could multiply those and then distribute the negative 2. All right, awesome. Okay, this is a good challenge here. So you have to match the factored form on the right side with the multiplied out, or I guess simplified form on the left side. So there's a couple of ways you could do this, and it's really up to you. But you can see here that you are to explain your strategy, which kind of connotes that there's more than one way of doing this. One way would be to multiply out on the right and match it with the left. Another way would be to factor on the left and then match it with the right. So go ahead and try all those. This is really good practice right here. Remember, when you factor, you got to factor all the way. All right. All right, go ahead and try those. Okay, now I'm back and I'm going to uncover all these for you. And I really hope you went through and did these. This is awesome practice right here. And really helps to solidify a lot of the, the special cases and other type ones. And I hope, like, if any of these are confusing to you, I hope you're doing a good job of putting a star or a question mark by it. And then when we go over it in class, when I say, are there any questions about the lesson, you're going to say, yeah, I have a question on J or I or whatever. Okay, so there you have it with those. Okay. All right, this is a flow chart for factoring completely. This takes into account everything that is involved in factoring binomials and trinomials. And what you can see is you start in the middle here, okay? And the first question you always ask yourself, is there a GCF to factor out? Okay, and then you just, and you need to kind of, you know this will become ingrained in you, but here it is in writing. So is there a GCF to factor out? If no, you're still going to continue on, right? We've seen plenty of problems where there hasn't been a GCF, but we've been able to continue factoring. Okay. If yes, if there is a GCF, then factor it out. Okay. The next question you ask yourself is the polynomial that I'm factoring a binomial or a trinomial? If it's a binomial, then you ask yourself, is it a difference of two squares? Is it in the form of a squared minus b squared? X squared minus 4, something like that. If yes, then factor it in the form of conjugate binomials, a plus b, a minus b, okay? If no, then what is left is prime. In other words, it can't be factored any further. And we use the word prime because, like a prime number, you can't break that down into any more factors, okay? So, and remember, if you take a GCF out, but then what's left is prime, you've still factored. You wouldn't say the whole thing is prime. You would only say that a polynomial is prime right from the start or completely if you can't take a GCF out, if you can't factor it in any way at all. Okay, so if it's just two terms, the only way you're going to factor it is by it being a difference of two squares. Otherwise, you can't, okay? All right, what if it's a trinomial? If it's a trinomial, you want to ask yourself first, is it a perfect trinomial square? Okay, is it in the form of, a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, okay? So you know that analysis. And if it is, then you factor it in the form of a plus b quantity squared or a minus b quantity squared, okay? If no, then you're going to try doing it the old-fashioned way or the star method, okay? If you can do it one of those two methods, then obviously factor it, do it, okay? If it's not factorable using either of those methods, then it is unfactorable, right? I mean, in other words, if we took a GCF out, then we're done, and that whatever we have there is finished. If we were not able to take a GCF out and we're not able to factor it in any way, then as I said, it's prime. And that's pretty much it, okay? With binomials and trinomials. We are going to do some towards the end, like 4-termed polynomials, and that's slightly different than this, but it's still kind of related to it. We'll get to that in a bit. Okay, so again, here are the guidelines. Take out the GCF if you can. Okay, so here we have 3x squared plus 6x. GCF is 3x, take it out, okay? Look for a difference of two squares if it's a binomial, or a perfect square trinomial if it's a trinomial. Okay, in this one, for example, x squared plus 4x plus 4, in other words, different problem than this one here. this is a perfect trinomial square, right? Because one of the square roots of this term times the square root of this term doubled is 4x. It factors to x plus 2 squared, quantity squared. Okay. And if it's not a perfect trinomial square, or if it's not a difference of two squares, then you need to try the old-fashioned way or the star method. For example, like this one. Okay, so let's just do a bunch of practice on this. So go ahead, let's do this one together, just to kind of get you warmed up with it. So again, first step, is there a GCF? Is there a GCF here? Yes, 3 goes into 3, 3 goes into 6, 3 goes into 18. All right, and x is in each of the term, x to the first. Okay, so we can factor out a 3x. Then what's left inside the parentheses? Well, 3x times x squared makes 3x cubed. 3x times 2x makes 6x squared. And 3x times negative 6 makes negative 18x. Now, if you tried factoring that further, would you be able to do that? Well, think about it. The factor pairs for 6 are 1 and 6, 2 and 3. And do either of those have a difference or a combination that will give us a 2? The answer is no. So that's as far as we can go. Now, we didn't factor this particular trinomial in here, okay? But would you say that the trinomial we started with is prime? The answer is no, because we did change the way it looked. We factored out a 3x. That's taking a GCF out is factoring. So this would be our answer. We would not write prime. Okay. All right. Go ahead and try the second one now. Okay, so I'm back. So hopefully you saw that you could take out a 7x squared, and that left x squared minus 4. And then you looked at that x squared minus 4 and said, oh, it's a binomial, and it's the difference of two squares. It factors to conjugate binomials, x plus 2, x minus 2. And again, how can you check these? Multiply everything out. Okay. All right, so here's 3 more. Pause the video and try these. Okay, hopefully on this one you took out a 3x, and that left you with x squared minus 4. Aha, look what we got there. A difference of 2 squares, x plus 2, x minus 2. Okay, remember, we're always factoring completely. Okay, so try the next one now. Hopefully you took out a 2y, and that left us with y squared minus 6y plus 9. It's a trinomial, so the question you're asking yourself is it a perfect trinomial square? Oh yeah, perfect square. Negative 3 is one of the square roots of positive 9 times y is negative 3y. Double is negative 6y. Ah, well then that means it's going to factor to y minus 3 quantity squared. And don't forget to bring that GCF down. All right, let's try the next one. What's the GCF if there is one? M, which leaves us with m squared minus 2m minus 8, trinomial. So you're asking yourself, is it a perfect trinomial square? Well, the last term's negative, so that's no, and 8's not a perfect square number. Okay, so it means we got to do what? We have to try and factor this the old-fashioned way or the star method. Bring my GCF down. I'm going to do the old-fashioned way on this one. So I know my first term, or my factor pairs for 8, 1 and 8, 2 and 4. Okay, what are my first terms going to be? Obviously, they've got to be m and m in this case. Signs. The last term's negative. We know it's going to be one negative and one positive. Just fill them in. Remember the rule of thumb, if you get the opposite of the middle term when you multiply it out, just switch the signs. And which one's going to have a difference of negative 2? Well, if I put a negative 4 there, when I multiply the inners, I'll get a negative 4m. And if I put a positive 2 here, I get a positive 2m. And can I factor any of these 3 factors further? No. Okay, cool. All right, so if you want to take a break, this is a great place to take a break. Now we're going to get into factoring the 4. So maybe, at least get up and stretch. Okay, all right, good. All right, factoring by grouping. To factor a polynomial with 4 terms, group the terms into pairs. And these are kind of, I like these because they're a little bit like a puzzle. And sometimes just like with a puzzle, there's more than one way of doing these. There's more than one way of doing four-termed polynomial factoring. And when I say there's more than one way of doing a puzzle, I mean, there's obviously the pieces got to go in the same place, but the order for doing it gets you to the same result. Okay, so what you're going to do is you're going to group them into pairs. We're going to factor the GCF out of each pair of terms, and then look for and factor out the common binomial factor. Okay, and this practice is called factoring by grouping. Okay, so let's look at this. Well, let's see. Maybe what I can do here with this one is let's group the first two terms together and the last terms together. And I can see that if I factor a GCF of x squared out of that first parentheses, what do I have left inside? X plus 3, okay? And what if, can I factor out of the second pair? What's my GCF there? Positive 2, right? What's left inside? X plus 3. Well, if you look at this entire blob and this entire blob, in other words, terms, in a bigger sense for this problem, what is their GCF? I'll give you a hint. It's in red. Yeah, don't they each have x plus 3 as a common factor? So our GCF between this oval and the purple oval is x plus 3. So I'm going to pull an x plus 3 out of each of those, okay? Okay, well, what would be left in the red oval if I pull an x plus 3 out? Yeah, just the x squared, okay? And what would be left in the purple oval if I pull an x plus 3 out? Just the positive 2. Then what you're going to do is you're going to look at what's left, x squared plus 2, and say, can I factor that at all? No, it's a binomial, and it's not a difference of two squares, it's a sum, and that one's on a square anyway. And then you always want to look at your GCF and make sure that you can't factor anything out of that. And obviously x plus 3 is not a difference of two squares, so you're good with that. Okay, awesome. All right, let's look at this next one. So, I wonder what we could do here. Remember, you can always change the order of terms if you want to. So, and again, there are more than one way of doing these. So what I did was I grouped the two terms that just have the x's together. All right. And that leaves what? That leaves the xy and the y together. Now I changed the order on them, but if you didn't do that right here, that would be okay. All right, what's the GCF of the first term, or the first blob, first parentheses? X, right? What would be left inside? X plus 1, okay. What can I factor out of the second one? Positive y. What would be left? An x plus 1. Okay, so out of this blob and this blob, what is the GCF? Yeah, it's colored for you, x plus 1. What would be left? X plus y. Can I factor either of those further? No. How could you check these? You could multiply back out and get to here. X squared, xy, x, y. Check, check. All right, why don't you give these two a shot? Give them a shot. Okay, I'm back. So, I kind of noticed that if I put these two terms together and I factor out an a squared, I'm going to be left with an a plus 3. So let's do that. Let's take an a square out, and I'd have, I'd have an a plus 3 left, and I'd have, obviously, there's nothing to really factor out of that, or I can think of it as factoring out a 1 if you want to think of it that way, I guess, right? Okay, so what is the GCF between this blob and this blob? Yeah, a plus 3. And then what's left? A squared plus 1. Okay, can I factor either of those any further? No. Sum of two squares, not factorable. Just a plus 3, can't factor that. Okay, and on this one, the way I did it was to combine the y squared and the 2y and make them a blob, and then do these other two, and I reverse the order. If you didn't do that, I think you would see it once you factor it out. But anyway, what's the GCF from the first one? It's a y. So what's left? A y plus 2. What can I take out of this one? Yeah, a positive x. And what does that leave? Y plus 2. What's my GCF between the two blobs? Y plus 2. And what does that leave you with? Y plus x. And by the way, the fact that I'm using these colors, if that is something that helps you, go ahead and use colored pencils for it. Why not? Make it a tool. Okay, so again, now we're going to take it a further step, just like we've done in some of the other lessons. Here we were just factoring, right? Now we're going to go all the way, and we're actually going to solve equations, quadratic equations, or in this case, or these, actually all these are cubic equations, so that we can have up to 3 solutions, and we're going to have to use the zero product property. So we're factoring once it's set equal to 0, and then using the zero product property. Okay, so let's look at this trinomial to start with. Is there a GCF? Yes. What's left inside? Can I factor that further? Yes. How? It's a perfect square trinomial because the first term and last term are perfect squares, and the square root, one of the square roots of 16 is -4 times w is -4w doubled times 2 is -8w. So it factors to a binomial squared of w minus 4 squared. And then I can set each of those factors equal to 0. And technically there are 3, right? W and then w minus 4 and then another w minus 4, but no need to do it twice with the w minus 4. So in this case, we end up getting 2 solutions. Remember, when it's cubed, you can have up to 3 solutions. Doesn't mean you have 3 solutions. Okay, let's try this one next. So why don't you try this one on your own? So pause the video and then let's come back. All right, so what can you take out? An x, what's left? X squared minus 25 binomial. So you're thinking perfect trinomial square? Yes. X plus 5x minus 5, right? Don't forget to bring your GCF down, Mr. Kalin. And then what do we do next? Zero product property. We're going to set each factor equal to 0. And what do we get as our solutions? 0, -5, and 5. All right. Go bottom left. Go for it. Okay, so what are we going to take out as a GCF? A c. What's left? C squared minus 7c plus 12. Is that, it's a trinomial, so is it a perfect square trinomial? No. Last term is positive 12. That's not one of our perfect square numbers. So we're going to go old-fashioned or star. I'm going to go old-fashioned here. Factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. Don't forget to bring your GCF down. What do my first terms have to be? X, or in this case, C, sorry, and C. Signs, last term is positive, remember, so that means either 2 positives or 2 negatives. So I'm going to go 2 negatives because the middle term is negative. And then, how am I going to get to -7? Oh, well, I could put in a -4 to -3 or -3 to -4. It doesn't matter the order. And remember, this is still equal to 0. Zero product property. So C equals 0, 3, and 4. So hopefully you got that one. Okay, what's different about the bottom right than the other 3? Yeah, we have not set equal to 0. We have to get these set equal to 0. That's the only way you can use the zero product property. So subtract 10x, take out your GCF. What's the GCF here? Be careful. 2x, good. So what's left inside? X squared plus 4x minus 5. Is that a perfect trinomial square? No. Last term's negative and it's a 5, so it's not. Bring your GCF down. Don't forget, remember it's set equal to 0. What are going to be the first things in my parentheses? Yeah, x and x. Signs. Last term's negative, so what does that mean? 1 positive, 1 negative. Only factor pairs for 5. The reason I didn't list it is it's just 1 and 5, right? Excuse me. How are we going to get a positive 4x? Well, probably by putting the 5 there and the 1 there. Yeah. Zero product property. x equals -5, 0, and 1. Okay. Again, if you're having questions on any of these, make sure you bring them up either at contact time or when we go over the lesson in class. All right, terrarium, excuse me, in the shape of a rectangular, prism has a volume of 4,608 cubic inches. Its length is more than 10 inches. Okay. The dimensions of the terrarium in terms of the width are shown. Okay, so you can see, look at the diagram. What do we have? We have 36 minus W inches, we have W inches, and W plus 4 inches. Okay, so when they say the dimensions of the terrarium in terms of the width are shown, they're saying, okay, well, W represents the width. So everything's based on the width. Okay, find the length, width, and height of the terrarium. Okay, all right, so volume is what? Length times width times height. Okay, so what's our equation going to be? What's the volume? Yep. And then we're going to multiply that times the length, the width, the height. Okay. Now, you might be saying, oh, cool, it's already factored for us. You're right, it is, but what's the problem? Is it set equal to 0? No. So what we're going to need to do is we got to move that over. Well, if we're going to move that 4608 over, chances are it's going to have to be combined with some constant when I multiply the binomial out. So I'm going to have to do all that. So I'm going to have to multiply this all out. So I did that. Okay, and I got 32W squared plus 144W minus W cubed. Okay, so what's the next step? Bring the 4608 over, right? Get it set equal to 0. And now we notice we have 4 terms, don't we? When we have 4 terms, what do we need to do? We need to figure out a way to group them. Okay. All right. So let's see, where are some that have common factors? Well, I know that these would have a W squared, and I wonder if 144 goes into 4608. Ah, it does. It does. Interesting. Okay. Well, let's see. It goes in, yeah, it goes in 32 times. Interesting. So again, let's factor. What is the GCF in the first parentheses here? W squared, or I'm going to take out the negative W just because it makes things a little bit cleaner inside the parentheses. And what does that mean? It's left. W minus 32. Notice how by factoring out a negative, this positive needs to become a negative. That way, when I multiply it back out, negative W squared times negative 32W, I get back to a positive 32W cubed, or W squared, excuse me. All right, and then we kind of figured out that 144 goes into 4608 32 times. So when I factor out a 144, I have a W minus 32. Okay, well, if you look at this blob and look at this blob, what GCF do they have in common? W minus 32. So we're going to take that out. Remember, we still have this minus W squared, and you could have that on the other side, the W minus 32. And then what would be left in our big blobs? Yeah. Negative W squared plus 144. Okay. All right. So what do we do now? What do we do now? Can we factor anything further out of here? No. Can we factor, well, I'm going to blow this a little bit. Can I factor, look what happens here if I take a negative 1 out of this. I get W squared minus 144, okay? And what is W squared minus 144? It's a difference of 2 squares, right? So I could factor that further to W minus 12, W plus 12, still bring down the W minus 32 and bring down this negative 1, okay? By the way, if you didn't want to do it that way, you could have just reversed the order of these and wrote this as 144 minus W squared. And then it too would have been a difference of 2 squares. You would have had 12 minus W, 12 plus W, but you would have had the negative 1 outside. Okay, well, we fully factored it. So let's set each of these factors equal to 0. So I've done that with the terms that have the variables in it. Notice I could set 0 equal to -1, but does that make any sense? Is that true? No. So you could either write that or not. Okay, and then we're going to solve for W. So W equals 32, W equals 12, W equals -12. Okay, well, we're only going to have one thing, which value for W is the actual width? Well, obviously the negative doesn't work, right? Okay. What about 32? Would that work? If W is 32, the width would be 32. The length would be 4. No, that doesn't work because the length must be more than 10, right? They told us that? Oh yeah, and that's not going to work because that would mean the length is only 4. So 12, right? So the width would be 12. What would the height be? 36 minus 12, which is 24. And the length is 12 plus 4, which is 16. And guess what you get when you multiply 12 times 24 times 16? Yes, 4,608. Quite a problem. Okay. A box in the shape of a rectangular prism with a volume of 72 feet. The box has a length of x, a width of x minus 1, and a height of x plus 9. Find the dimensions of the box. Similar to what we just did, but kind of easier numbers, I think. All right, so what would our equation be to start if we know what the volume is and we have ways of representing our dimensions? Yep. Okay, so what are we going to need to do? Too bad it's not set equal to 0. This would be such an easy problem. But of course, you're never going to have a prism with a volume of 0 or anything with a volume of 0. So we got to multiply out. So I multiplied these two together first, and then I'm going to distribute the x. I'm going to bring the 72 over, right? Okay, how might you group these? Well, let's see. Ooh, 9 and 72, they would have a GCF of 9, and then I'd have an 8. Oh, and then there's an 8 there. So maybe that's the way to go. So let's group them like this. What would I take out of here? Yeah, and then what's left? X plus 8. And then I'm going to take out a 9 from here, and that leaves another x plus 8, doesn't it? Okay. Between my two blobs here and here, what's my GCF? X plus 8. What's left? X squared minus 9. Okay, now can I do anything else? Can't factor x plus 8 any further. Difference of two squares. We can factor further there, right? What does x squared minus 9 factor to? Conjugate binomials of x plus 3x minus 3. Okay, now we can set each factor equal to 0. Oh, and let's see how that's a equals. That's not right. That should be a plus sign, shouldn't it? See, no one's perfect. Okay, and obviously x is going to equal -3, 3, and -8. Okay, can we have 3 answers like that? No, obviously the negative's going to work. No, you can't have a negative length. Does 3 work? Well, if x is 3, then what are the other dimensions? 2 and 12. And what's 3 times 2 times 12? 3 times 2 is 6, times 12 is 72. Check, check. All right, and then here's your exit ticket. Solve it. Go. All right, I'm back. So first I'm going to pull out my GCF, which is what? Looks like they all have x cubed and they all have a 3 as a factor. And I'm left with x squared minus 2x minus 15 inside. It's a trinomial. Is it a perfect trinomial square? Nope. Last term's negative and 15 is not a perfect square number. Okay, I'm going to go old fashioned. You could always go star if you wanted to. And what's going to work here to get me a difference of 2? 3 and 5 would work, right? So x minus 5, x plus 3, set x each factor equal to 0. So what does x equal? -3, 0, and 5. And since this is not a word problem, these are all solutions to the equation and we're done with it. And you could check it by doing what? Yes, plugging in. All right. Well, that does it for chapter 7. Woohoo! All right. Come ready to go with questions on the lesson, and I will see you real soon.